I'm Aiden, founder and CEO of ThermoAI. We are using artificial intelligence to optimize combustion, saving millions in fuel and reducing harmful emissions. Perhaps the most important innovation of all time was the invention of electricity. It is literally the technology that underpins and enables all the other technologies you see presented at events like this. And yet, how to generate that electricity is a process that has remained relatively the same for decades or even centuries. Much of the equipment in these facilities would look more at home on the set of a 1950s sci-fi film than a modern-day server farm. And despite having a massive amount of sensors, much of the tuning of these machines is still done based off operators' gut guesses. Like this operator, manually viewing the flame to gauge whether he thinks the flame is running too rich or too lean. And as a result, power plants currently operate at only 33% efficiency, meaning 2/3 of the energy in the system is wasted. This costs the operator of these facilities tens of millions of dollars in fuel, reduces the lifespan of expensive industrial equipment, and produces more emissions. We have developed an AI that increases combustion level efficiency 3 to 5%. Now I get, that might not sound like a lot to a lot of people until you realize that these facilities are spending upwards of $500 million a year in fuel, meaning our savings to one facility could be over $25 million. And there are over 62,500 power plants worldwide. Currently, we are working with 5 top multinationals, and what we are working on is so exciting to them. They're giving us real data from live plants. So how does it all work? We start by using that historical data to recreate the plant in a simulated environment. And then our optimizer finds all the hidden inefficiencies in the process that the current controls miss. You see, the thing is, millions of external factors influence the exact chemical reaction. The weather outside, the humidity content, the fuel quality, all of these things change the exact chemical reaction. Without the help of our AI, calculating all these factors for a human operator is simply impossible. We supercharge human operators by giving them real-time recommendations via our easy-to-read dashboard system. And every recommendation they take helps to further train our AI, meaning the more they use it, the smarter it gets and the more money they save. So currently we are working with 5 different companies in different countries around the world with different fuels, proving the truly international potential of our AI. And the exciting thing as we move forward to on-site trials is these are multinational companies. They have thousands of facilities, and they have already indicated a clear intent to deploy all their facilities if we can show anything above a 1% increase in efficiency. And we're already seeing 3 to 5% in our in silico operations. We're also getting positive feedback on our efficiency services and pricing model. This minimizes their risk and maximizes our earning potential because we take a percent of what we save them in fuel costs. So the example that I gave earlier, $25 million savings, that would mean a recurring revenue of over $6 million for ThermoAI. And the more they use it, the more their efficiency goes up, the more our recurring revenue goes up. So this is an amazing market opportunity, and we've assembled an amazing team to help tackle it. Catalina is a chemical engineer and sustainable energy researcher whose research in combustion optimization was actually the inspiration for ThermoAI. David Watson is a machine learning PhD out of Oxford University who's given talks at MIT and writes for The Economist. And I'm a twice-published enterprise sales expert, former marketing consultant in Manhattan to Fortune 500 companies, and a contributor to VentureBeat's AI session. Now the timing for our AI could not be better, because combustion optimization not only reduces fuel consumption, but also reduces emissions. And companies all around the world are struggling to meet stricter emission guidelines, and our AI can be another tool to help them do so. And we can be a major force in reducing overall global emissions because for every 1% of efficiency we're able to gain at a power plant, that is like taking 288,000 cars off the road. Meaning the net environmental impact of our current pilots would be like taking 7 million cars off the road. So if you want to invest your money or time into a company that makes a difference but also makes a fortune, come talk to me. And together we can see which milestone we can hit first. 1 billion cars off the road or a $1 billion valuation. Thank you.
All right, if you have questions, please raise your hand and wait for the microphone so that the camera can pick you up.
Hi, very good presentation.
Thank you.
I was wondering, I might have missed the competitive market. Who are your competitors?
Yeah, so the main things that you see right now in the competition marketplace, and it's a little murky, which is why we kind of left it out of the slides. So you see things like Uptake, which is like a $2 billion company, but what they generally do is just throw a generalized neural net at any problem. Give me your data, we're going to optimize it. And obviously, machine learning, even though it's in the early phases, it's kind of like a car. There's no model that's kind of perfect for every problem. So we're specifying in the combustion processes, which is why we're able to outperform generalists in that. And then the other option is just kind of generalized consultants that can come in and add heat tape to things to kind of reduce thermal loss. So it's not a direct apples for apples, so that's why we don't have it in the presentation.
Thank you.
Sure.
Maybe I missed this. Your raise, are you guys raising how much? Or?
Yeah, we're currently doing a $1.4 million seed round.
Have you guys raised already?
So we just went through Techstars, and then we were in Startup Chile. So all in all, this year we've taken in just over 200,000, but not. This will be our first kind of venture-based raise.
Good job. It seems neat. With solving this problem, it seems like data is going to be your toughest problem to really get into the AI. And how are you guys sorting out, pulling in the right data streams and so forth?
That's an interesting question, right? So when we first started this, I kind of went to these multinational power companies, and I was like, look, I think I can save you money, give me your private data, which I even have to say I didn't really think would work. But we did, even early on. Because the benefit of what we're offering them is so big that, we're under NDA, so I can't disclose which companies, but yeah, we were able to get the data pretty simply, actually. The hardest thing is actually getting them to implement the AI's results, but actually getting the data and modeling it, we've had a lot of success with that.
What stage are you guys in the testing and working with these companies? Are you guys at step 1 to 10? Are you at 1, 3, 6? When do you see them, ready to, go and pay for this and say, okay, let's sign a contract and get this done, and then suddenly you guys, are a company or basically, are a revenue is kind of what I'm interested in.
Yeah, sure. So like I was kind of saying in the presentation, the way that we're kind of looking at this is the first step is we get the data, and then we create the simulator, we create the optimizer, and we figure out what they could have saved versus what they did do, what our AI's performance would have done, kind of thing. The next step and what we're raising for is to do the on-sites. So now that we've started working with them, we've got their data, we've created the models, now we want to implement it live on-site, and that will actually be our revenue. So that's what we're raising for, and we hope to have that accomplished within the year.
So I'm curious with the purchasing cycle. So I'm assuming this is a one-time buy. I mean, if they pick you up, they're with you for 60 years, 100 years, etc. I mean, it's a big investment. So back to the competitive question, for such a big purchase, how are you really going to be different from your competitors?
I think that's the main thing too for us versus what you see in like Uptake or whatnot. Because we're taking a percent of what we get on the results, and we can kind of come through as the ESCO model, that does kind of differentiate us, and then we come in through as an OPEX expenditure versus CAPEX expenditure, which is a lot easier for them to kind of put into their books. And then as far as how we stay on the books for them is, they're benchmarked against our efficiency. So once they're kind of in with us, the operation would be suicide if they took us out and they drifted backwards, even if they wanted to go to another provider. And that's where the specificity in combustion really comes through for us. Because even if they go, oh, we don't want to pay this much, and maybe this person can do it cheaper, if operationally they go downwards in efficiency, it's just not tenable for the operations manager. So it seems to give us some good defensibility as far as long-term value.
Do you think the efficiency improvement could be scalable? So once people get in and we get them to 5, will you be able to get them to 10? Because if their starting point is 33, that's ridiculous.
Yeah, this is an interesting question. It depends who you ask. So I tend to be more optimistic than David. To give you an example, DeepMind did something similar, but they did it onto the loading of the electricity onto the grid kind of thing. They did it with their hydro plants, and they saw a 70% increase of efficiency, which was just staggering. So it's hard to say what the reinforcement will actually do, because right now we're doing it in silico, and so we're confined to any conditions they've actually done in the past, which is limited. Once we're actually in, and then there's a reinforcement learning, I think we're going to do much, much higher. And to your point, I think there's a much higher upper end to that. but only time will tell.
Because over time, that gives you the possibility of saying, okay, so we've saved you something 25% over the last 5 years. All right, your new benchmark is there. And if we can save you more, we'll get a percentage of that, or we'll just get a subscription.
Well, and I think this is an interesting thing to kind of explain on this is, it's not like we're even like tuning a piano or anything like that. It's not like, oh, they're tuned. The problem in why this has been so vexing for operators up until now is it's, shooting at a target that's always moving. Because right now they have like a range. So the way that they literally calculate this, they have a table and they go, well, how much, what's your fuel flow? Okay, your airflow should be a ratio of this. But that's obviously never the case. That's an average curve. But the actual point deviates constantly, so they just do the middle value kind of thing. So really they can't ever, it's not like they're tuned. If they don't have, so it's kind of a predictive system that's kind of anticipating where the set point's moving at any given moment, they're going to drift back downwards in efficiency.
So right now, they're just giving you the data, nothing's automated, correct? Like they're just giving you the data, you're providing a model, but they're not writing that back, I guess, to their PLCs or programs or anything like that, taking in those set points that you recommend. Is that correct?
Yeah, that's so we're raising the money so that we can actually do that on site, because we don't really want to bootstrap that part of the process, but yeah, that's going to be the next step with our pilots.
Okay, so the values that you're giving them, saying, if you change your set points to X, Y, and Z, you're going to see better efficiencies. Are they taking those recommendations and seeing that currently, or are they just, right now in the model phase?
It's all been in silico. Yeah, until we get to the, finish the fundraising, we've not actually had them implement in production any of our recommendations because it's just going to be a lot more intensive.
When it looks like when you actually have the system set up and you have somebody signed on and there's a user, are you guys having your AI back into their systems and it's automated from the AI suggestion to the actual implementation of the solution? Or is somebody going to be reading this on a daily or minute-to-minute basis and going and making the corrections in their machine?
So, I mean, the way we actually put that, and the reason we have the dashboard, the best answer is it should be the first one. The reality is people are not always comfortable with automation. They'd much rather let a person make a bad decision than the idea of like an automated bad decision. So this is almost a build of comfort for them so that they can do it via their human operator as a kind of a firewall kind of thing. But yes, ultimately the best thing is just go back in through the system to the SCADA system and make adjustments to the airflow automatically.
All right, and we'll get to you, James. All right. What can the community do for you? What are you looking for here?
Well, it's funny too. So we focus a lot on power in this because it's easier for people to wrap their heads around. We're actually dealing with anything combustion related, right? So any type of boiler, any type of burner type system, and we're desperately looking for more pilots here in St. Louis because right now we have them all around the world, and I'm tired of constantly being on an airplane. So if you guys know anybody, even smaller, where I think we went very large at first. It was like, oh, this is going to be great having these big ones, but they're slow. And we do want to move faster, so if they're kind of smaller facilities, steel, cement, food production, what have you, most of these things are going to have some type of boiler system. We would love an intro to them so that we can get kind of smaller pilots moving a little faster, closer to home.
Sorry, you answered my question.
There you go. I knew it was coming. I saw it in your eyes.
All right, any more questions? All right.
All right, thank you all very much.